Okay, let's get the next session underway. We have 3 incredible talks for you. We're going to start off with a deep dive, an expansion of what you've heard already about how Flower has evolved as a framework, as a platform, as critical infrastructure for building federated systems of all kind. I'm joined here by Javier Fernandez. He's at Flower Labs. He's going to tell us all about it. And so over to him. Thank you.
Thank you, Nick. Well, I'm here once more to talk about not the Flower framework, but we'll see why we are calling it a platform in much more detail now compared to previously. So by now you know that Flower has been designed with compatibility in mind since the very beginning. It's compatible with your favorite tools, including tools that have been around for a long time, like PyTorch, TensorFlow, Pandas, and others. And it's also compatible with newer tools like MLX if you are developing federated applications on the Mac, or even super new tools like Hugging Face Legobot library, which was, as William presented, is one of the new exciting examples in Flower, where we show how you can set up federations of robots that collaboratively train a single model. Because with Flower, you can really do you can run all these type of workloads. There is no surprise that many of you, whether you are in industry or in academia, you have been applying Flower to many sectors, in sectors as important as transportation, finance, health, and more. And because of this, we know you can apply it in those sectors. You can apply it also in cross-device setups, where you run Flower applications in the devices that you own, maybe the devices that you even wear, such as smart watches, for example, if you want to build the next-gen human activity recognition model. The only way to do it is with federated learning. So we know, and you know, that Flower is a powerful framework, but this is all news. We knew this for quite a while, and in fact, we were talking something about the same lines in the last Flower Summit. In the last 12 months, we have introduced a series of key components that I'm going to enumerate now, and I'm going to briefly talk about them, but I'm very happy to talk in far more detail later. And together, all these components that I'm going to present is why we are calling Flower now a fully fledged platform. First is the Flower CLI, which we'll see in more detail today, and in greater detail tomorrow, which is the best way to create a Flower app from scratch, from some built-in templates we have, and to also execute them, whether you are running them in simulations on your laptop or workstation, or if you want to run them in deployment. The way to run them is identical. It doesn't matter if you are simulating them or running them for real. We have formalized what the Flower app abstraction is, and this means that there is a unified way of writing how the server-side logic and the client-side logic works. And this is great because by following these guidelines, we can guarantee you that your application will run in simulation and in deployment. When it comes to running things in deployment, we have introduced 2 infrastructure-level components that we call them the superlink and the supernode. You can think of the superlink as the server that will relay messages between your strategies, like the orchestrator for your applications, and the clients, which are the ones that have the data. We call the clients now supernodes. And as we heard from Daniel earlier in the keynote, we have really redesigned from the ground up how the deployment runtime works, and also how the simulation runtime works. And they both share a common backbone, and that's why you can go from simulation to deployment and between them without any changes to the code. And of course, we cannot forget about Flower datasets. It's one of the greatest libraries that live in the Flower ecosystem. It allows you to simulate different scenarios of, in particular, data heterogeneity-rated scenarios. So you can test all your algorithms in as challenging and difficult scenarios as you want. So once you are ready with your algorithm, you can deploy it in the real world. There, you won't have control over your data, but because you can control how your data is partitioned in simulations with Flower datasets, your application should work pretty well. And because of this, I'm repeating myself a little bit, but it's really, really remarkable, I think, that we can develop a Flower app We can run it in simulation right away. We can increase the size of our simulation very easily, and without changing anything in the code, really nothing, we can run it in deployment. And this cycle is really complex to achieve, but I think in Flower and with our amazing team and contributions from the community, we made it. But you don't have to trust me, so I'm going to show it to you right now. So for that, I have here VS Code, which, as many of you know, is one of the most popular IDE for developing pretty much anything. And what I'm going to do is I'm going to use one of the Flower CLI commands, which is FLWR, which is short of Flower. I'm going to say Flower new. And what I'm going to be creating is a Flower app. So I'm going to give it a name. For example, demo 123. And this is going to guide me through some process with a couple of extra questions. Just two, so don't worry. And it's going to ask me for my username. So I'm going to type my name. You can write anything you want, really, as long as there are no spaces. And then it's going to ask me for what Flower template I want to use. All these are different templates for different Flower apps. You might want to choose the PyTorch template or TensorFlow template, or if you are, you want something maybe more exotic, you want to go for JAX, you can do that too. And when choosing one of them, you will be, if you were paying a lot of attention, you will see that a new directory appears here. This is a Flower app. So it's a compliant Flower app with a structure that is expected for all Flower apps to have. And if I open just one of the files, for example, the server, I would see that we are using very familiar high-level components like the fedaverage strategy. If you want to use something different, like fedprox or fedadam, you would just change this line of code. I'm not going to go in detail through all the code, because you can run this Flower new command exactly as I did yourself on your laptop. But what I'm going to do is I'm going to run it, which is one of the best parts of the new Flower app abstraction and the Flower CLI. So for that, I'm going to use the Flower run command. And I'm going to put the name of my app, which in this case is demo 123. And just by doing this, by default, Flower apps will run in simulation. Most of you have already been playing around with this, because this has been around for a few months now. And by default, the config file of my Flower app is using 10 supernodes, which is equivalent to, say, 10 clients. What if I don't want 10 supernodes because I'm expecting to see 500 clients on my real-world federations? So to make the change in simulation is really as easy as changing the 10 to a 500. And if I run it again, well, surprise, surprise, now instead of sampling half of the 10 clients I had before, now I'm sampling half of the 500 clients I have. And what's happening here in this round is really I'm training 250 individual models that they get aggregated by the strategy. And you can see that this simulation is running pretty efficiently. What about the infinite loop cycle going from simulation to deployment? So in order to do that, what we need to do is just to add we need to tell our Flower run command where our superlink, which is where our server is. Typically, you will deploy this somewhere in the cloud, maybe on premises or somewhere else. And we call this, we refer to this as federations. So I'm going to create a new federation, which I'm going to name, for example, remote. This could be really anything, any string, as long as it doesn't have spaces. And I'm going to point it to the address of my superlink that I have already deployed. This is being deployed locally on my laptop, but the process is identical, even if it's running somewhere in a public cloud. So for that, I'm going to put the address and the port. I'm trying to do with one hand. So, and the other thing I need to pass, because we want this to be using TLS, so everything is encrypted, we're going to pass our certificate, which I have already downloaded. So for this, we just need to write root certificates. And I'm going to pass the path to my certificate, which I know where it is, so it's here. And just by doing this, now if I want to run this for real, in a real deployment where there are super links, and I think I have 7 super nodes, this means 7 individual Docker containers, I will just do it almost identically, but thank you very much. It's great to see a lot of attention. Thank you. So now if I want to run it on the remote federation, if you pay attention, here you can see that default federation will be pointing to this one, simulation. I want to use the remote one, so I just need to say remote. And like this, I want to also, for example, stream the logs because this is going to run remotely. So now this is really running remotely. What has happened is that my app has been, all the code in my app has been bundled into a single binary file. It has been sent to the server, the superlink, and the connected clients to the superlink were able to pull this code and execute it. And you can see, as I mentioned, there were 7 clients, so we are following the same logic, sampling half of them for training and all of them for evaluation. We'll go back to what results are being generated with this later in this talk, so stay tuned for that. So going back to the slides, that was a quick demo on how new components in Flower work. Putting everything together, we have the Flower CLI with commands that we have already seen, Flower new and Flower run, but there are many others like Flower less, Flower log, Flower stop. You will learn more about them tomorrow morning. We have the Flower apps abstraction, the superlink and supernodes, and new simulation and deployment runtimes. And all this that we have seen is possible thanks to high-level APIs that we refer to them as strategies, and also the client, high-level API client abstraction. But what I want to talk about are the strategies. So strategies are really what took Flower to the next level a few years ago. And we are also very grateful that many of them have been implemented by people like you from the community. Many of them are from top-tier papers from the FL literature. And the great thing about strategies is that they are modular and highly customizable. In fact, I think one of the talks this morning, we heard that somebody developed a custom strategy, which is amazing. They are really easy to work with. They power the best research, and we have seen some of it today, and we'll see more tomorrow. And they are also loved by our partners, because out of the box, you get all the complicated logic to make sampling of clients done in a particular way, and more importantly, they come with built-in algorithms on how to aggregate the models that get trained in the client side. But sometimes we were wondering if there is a better way to write Flower apps, a better way that give us more control than what strategies allow us to do. And we think there is a better way. We call it the Message API. And to tell you everything about it, here is my colleague, Pan.
Thanks for the kind intro. So, hi everyone, I'm Pan, a research scientist from Flower Labs. So before we jump right into the topic, I'd like to spend some minutes talking about the initial motivation for us to do this. So we always receive messages from lovely Flower enthusiasts asking, oh, I really like the abstractions of strategy and client, but I was wondering how to do early stopping. What if I have multiple models? I want to do analytics. I want to do things asynchronously. And I saw there's something called parameters. Can I put gradients inside it? Things like that. So these questions basically asking, how does Flower work? So how does Flower work? Oops. So I think, well, it is definitely possible to make that happen just with strategy and client. But there's always too much to learn. And we expect that anyone can get started with Flower easily, even if they know nothing about Flower. So let's just strip Federated Learning to the bone. So there's a server. We call it a server client. A server app. And here's a client. We call it a client app. So to do something federated, they need to exchange message which is actually just a specialized dictionary, a Python dictionary, containing parameters, metrics, configs, or anything you like. So that's actually everything about low-level message API, which is available today. Let me give you a short example. It's actually a full example if you remove the dots. And here on the left-hand side, we have the implementation of the server app. And we create a message. And when we send the message received by the client app, it will be exactly the same message, or say the same Python object sent by the server app. So you don't have to know what happened on the hood, but it's just the same Python object be delivered from the server to the client. And when the client app creates a response and returns it, well, basically echoes it, the same message, or say the same Python object, goes from client app to the server app again. So that's how low-level API works. And that's really everything you need to know to get started with Flower low-level message API. So that means you will have full control of the federated learning flow. You can basically do anything you like. And yeah, that's the amazing part of it. But having full control means you need to write some code, definitely. It's not something out of the box. So although we already have low-level API available today, but we are also happy to share with some early prototypes of high-level message API. So here's the code for sampling clients, or say sampling nodes. So that can be done with a sampler. And here's the code to create messages for each of the client. And that's a communicator. And finally, the most code comes from aggregating message replies from all the clients, aggregating metrics and their individual static, or say any other model weights. So that can be replaced by a single aggregator. So if we put them together, we can see a nicely put for loop. And in each server round, we sample the nodes and create message for each of them, and send a message, and finally aggregate the results. So what if I want even less code? I want something out of box, just like strategy. That's also possible. Well, we have sampler, communicator, and aggregator. We just need something to orchestrate them, to glue them together. So that's orchestrator. With one line of code, you can complete the entire round of training step in federated learning. From passing the model to load the model back to the load the static back to the global model. So with low-level API available today, we also have something amazing on our roadmap. First of all, is obviously the high-level message API we just showed. Also, we'll bring native support for secure aggregation and differential privacy with message API. And finally, we're also interested in support decentralized FL and hierarchical FL and potentially other network topologies with message API, because it empowers, basically allows us to do anything. It's just it just flows naturally because it's very easy to understand, and we don't bring any extra limitations on them. And that's everything about message API, and for the low-level part, it's already available today. And I'm going to hand it back to my colleague Javier, who's going to show you something really amazing in the next few slides.
Okay, thank you, Pan. One thing I want to say is that the message API, go try it, is really amazing. And also for those of you that are big strategy followers, don't worry, they are not going away. But the message API is a different way of doing things, and over time, I think they both will end up merging. We'll see. So, but if you have some feedback, we are really welcoming all type of feedback. So the big thing, which already we show you during the keynote, is that we are working on a Superlink UI. This is going to allow you to not just see information about your experiments, but also see a bit of information about the federation where your experiments are running on. So we see this as a unified interface that will be very useful for scientists, but also for the admins, because at the end of the day, if you have a network of, for example, hospitals or banks or other type of institutions where there are very high stakes, someone has to manage those federations, someone has to enable a hospital to be connected to another server. So for the admins, this type of UI will be essential. And of course, scientists and admins will have a different view of the dashboard. So I can show you a quick overview of it. You saw simple images earlier, but this is how it feels like. So I submitted a few rounds earlier. In fact, the run I demoed earlier is somewhere here. I will open one of the runs I did earlier in the morning, which was with a Flower app called Message API Demo. So if I see it, I can see that some of the metrics my server app is generating, like accuracy and loss, they get natively displayed. I can see also what was the run config I used. For example, I decided to sample half of the clients. The learning rate was 0.01, and so on. Of course, because the apps get their own identifier, I can also select other apps. So I can compare how the same app, but using different hyperparameters, perform in my federation. And of course, I can see things like the logs that those particular runs generated. If I want to get an overview of what are the nodes in the federation, which, by the way, these were the nodes. Each of them are super nodes where I submitted my remote workload earlier in my demo. I will be able to see information, for example, like who they are. They have a node ID, but where they are based. Or this will depend a bit on what kind of federation we are talking about. Different industries will have different requirements. And this is a quick overview. We see there are 7 super nodes, but you can think that there is a lot of functionality that can be built on top of this. For example, admins of the super link might be able to allow super nodes to join or deauthenticate super nodes whenever a project has finished, for example. We'll have much more to share about this later in Q2 and Q3. So wrapping up the talk, because we are way over time, I just want to conclude with something that Daniel mentioned earlier in the morning. So since the last Flower Summit, we have done 10 major releases, but other patch releases. And there are a lot of functionality that we don't have time to talk about now. Things like the FAB delivery mechanism, which is the mechanism by which the code I develop on my laptop gets communicated to other members of my federation. Or how the isolated execution of my client app works. Because if at the end of the day, if I have a server in the hospital, I don't want the client app that somebody else wrote to be able to do anything with a file system. So there are isolation mechanisms, so everything is compliant. Node authentication features, so we know that the supernodes are who they say they are. And also custom message handlers. So now you won't have any limitations on what kind of messages you can create. By default, you have train, evaluate, and query, but you can create as many more as you want, which is something native to the Message API and really will make your Flower applications way more versatile. And this is everything I had to share. If you want to try the Message API, we have an example in the GitHub. If you scan it, it's here. If you prefer to go to GitHub directly, it's called app PyTorch. And that's it. Thank you.